And it's supposed to help discover things in science. It's supposed to help solve energy problems. And it's also supposed to help the world with nuclear security. Nuclear reactors, nuclear weapons, stopping to prevent the spread of them and so on. So it's a very broad range of activities. And my job is to look over the science and technology across the whole department. Make sure it's good work, try to understand where people should be talking to each other and they're not, try to understand what new things we should be doing, and to talk about science to other parts of the government and the outside world. So it's a wonderful job because it's got a great scope, but I don't have too much real responsibility. So I don't have to worry about all of the problems with budgets and people and space and all the things that a real responsible job has. I did such a job for 10 years, as Alicia mentioned, when I was provost at Caltech and helped run Caltech. I decided it's much more fun to have the fun stuff and not so much of the responsibility. Have I ever done anything important and useful and made a discovery? Yeah, I have discovered some things that I think were important. They have to do with ways of building models of nuclear phenomena. One of the things I got interested in and helped move along before I moved into the administration had to do with climate, a very important subject these days. And we learned how to measure very simply how shiny the Earth is, how much sunlight it reflects by watching the moon. And that was a lot of fun. I worked with a small telescope we built and helped analyze that. So, yeah. All people, actually, I'm a theoretical guy. And so my design skills are not great. Probably nowhere near the kind I've seen here. But I'm pretty good at thinking math. And so you get some friends who can do the building and design. Right? And you look at the answers together. So the project still goes on. In California, in Spain, there are small telescopes that every night are watching the moon, and by observing in a certain way, we can understand how shiny the Earth is, how the clouds are changing, how the ice is changing. That's really cool. Yeah. What I can tell you is that the government, my boss, the Secretary of Energy, is in Houston today with a team of scientists, some of whom are my friends, trying to help BP figure out how to stop the leak. Right? And you can read in the paper some of the ideas that are being tried. All I can tell you is everybody's working very hard right now to get that thing stopped, and then we can do it. The government is working with the companies. It's, I'd never been in the oil business until 5 or 6 years ago, and it's absolutely amazing what people can do. Go down 30,000 feet and 5,000 feet of oil, 5-6 miles down. It's quite amazing. And know where the oil is, and then get it out, and still be able to make money do it. Yeah. The oil companies, Exxon, Shell, BP, it's not easy. It's really amazing engineering. And you're spending billions of dollars when you do one. But pretty cool. One of the interesting questions to ask is, you're going to go drill a hole in the middle of the ocean, right? It costs $100 million just to drill the hole, right? There's a ship that's got to go there and send a pipe down and start drilling and so on. You better know where the oil is. You better be sure, otherwise you wasted $100 million, right? There's a whole other bit of science about how you know where the oil is. Question? I'm sorry. Well, it's got to be enough. You got to believe that there's enough there, and we have ways of knowing, again with science, about how much oil is down there when we find it. And so it's got to be worth it. And that depends a lot on how much does it cost you to do all this, how much can you sell the oil for. So it's a really complicated job. How do you know where the oil is? Right? So you got like 20,000 feet of pretty hard rock. And then you got some rock that kind of got holes in it and has got the oil in it, like a sponge almost. All right? And when you send sound through the ground, if you can send sound through the ground, it'll travel differently through the oil than it does through the hard rock. And so what you do is you got this boat on the surface, pretty big boat, that's got a big noisemaker on it. It's an air gun, as it's called, and every 10 seconds it makes a really big bang in the water. And behind the boat are about 6 streamers, cables. They're about 2 miles long, and every 50 feet on each of those cables is a microphone. And it picks up the sound that got reflected from the ocean bottom after it traveled down into the rock, reflected off the oil, and then came back. And the boat just steams along. Every 5-10 seconds it makes this noise. The microphones record what they heard. And then after a lot of computer work, sometimes years later, you can say, aha, there's a good chance that there's going to be oil right over there. And we think about how much. It's not always perfect. They're pretty good now. About 90% of the time they get it right. But sometimes they miss. And so that's how you know. You can make a pretty good guess. Yeah. Actually, it's many microphones spaced along, because how the sound reflects at different angles tells you what not. It's a really impressive but difficult business. So let me say a word about science and engineering generally. Science and engineering are really useful because not only could you imagine, if you wanted, working in them, but they also teach you how to think and give you tools that are important no matter what field you go into. Whether you go into business, or you go into law or medicine, the training that you get as a scientist or engineer really helps you think about problems in a very different way than if you had not studied it. So you should realize it can be a gateway into many other careers as well. What should you be thinking about? Well, look, it starts with geometry, algebra. We've had a little bit of algebra, right? Then you learn how to put them together in what's called analytic geometry, maybe. Calculus, eventually, which is describing mathematically how things change. All of those are important, and they're a kind of understanding that has been built up over centuries by people. And it's really both interesting practically, but also culturally to understand how that's been built. Science, biology, really important. I think if I had to do it over again, I'd probably end up as a biologist or an earth scientist. Biology is so interesting these days because we have new tools. We can understand about genes, how the genes work together. We're starting to understand how brains work. All of that's just wonderful science, and obviously very important. So biology, earth science, how the earth works, again, exploding in our understanding. And then physics, chemistry, they're all pretty interesting. What to do during the summers? Read a lot. These days there's a lot of material on the web. You can teach yourself. Summer schools, summer camps that focus on science. I think those are all ways of getting involved. You get a little bit further along, you can do a summer in the national laboratories. There are a couple of national labs in this area. If you're really interested, find out what it's like to really work in a science or engineering environment. So those are some ways to do it.
Let's thank Dr. Koonin for coming again.
Good job. Even though you might think that this is a classroom exercise, this is a lot closer to what people do in the real world than you might think. So have fun, pay attention, and good luck.